We're going to look at substitution with word problems. So what we're going to do is we're going to write a system of equations and then we're going to solve it. So Lily goes to a clothing store and buys shirts and shorts for the summer. She buys 2 more shirts than shorts and buys a total of 8 items. How many of each item did Lily buy? So the first thing that we have to do is we have to define what our x and y values are going to be. Now we could pick any letters that we want, but I'm just going to use x and y for this one. So x is going to be, let's see, number of shirts. And y is number of shorts. So it says that she buys 2 more shirts than shorts. So if we have shirts and it's 2 more shirts than shorts, so whatever the shorts are, if we add 2 to that, that gives us the number of shirts. It also says a total of 8 items. So x plus y equals 8. We're going to solve this by substitution. We're going to take the y plus 2. We're going to plug it into, not the y, into the x. And when we do that, what we get is instead of an x, we have a y plus 2. And then we have another y, and that's equal to 8. Y plus y is 2y. I subtract the 2 on both sides, and I get 6. So y is equal to 3. So that means there are 3 pairs of shorts. And then if we look at it, if we plug in a 3, 3 plus 2 is 5. So there are 5 shirts. So the number of shirts is 5, and the number of shorts is 3. Now, Grant receives $49 for his birthday in bills of 1s and 20s. He receives 1 less than 5 times as many 1s as 20s. How many of each type of bill does he have? So let's use D for number of dollars. And we'll use T for number of 20s. So the first thing we have to do is write our first equation. It says he receives 1 less than 5 times as many $1 bills as $20 bills. So when we're looking at this, what we're going to do is we're going to take our $1 bills, which is D, and then we're going to go 5 times T, which is the $20 bills, and then it's 1 less than that. So our second one is he has $49. So we know that a dollar is just $1 and a $20 is worth $20. And that's a total of $49. So we're going to take our expression, we're going to plug it in for the D. So we get 5t minus 1, this whole expression. And we could put a 1 right here, but it's not going to make a difference. And then we have 20t is equal to 49. 5 plus 20 gives us 25. And then we have minus 1 is equal to 49. I'm going to add the 1, and that gives me 25t is equal to 50. So when I divide by 25, I get t is equal to 2. So there are number of 20s would be 2. And then I have to find the number of 1s. So I'm going to take the 2, and I'm going to plug it in. 5 times 2 gives me 10. 10 minus 1 gives me 9. So that means there are number of $1 bills would be 9, and number of $20 bills would be 2. Pause it for a second. See if you could do C and D on your own. So, looking at letter C, Maddie goes to buy some hoop earrings. There are little hoop earrings and big hoop earrings. She buys 3 times as many little hoop earrings as pairs of big hoop earrings. If she bought a total of 16 hoop earrings, how many of each type did she buy? So I'm going to use L for, and I probably should make a cursive L so it doesn't look like a 1. So L for little hoop earrings. And then I'm going to use B for big hoop earrings. So when I'm writing the equation for the first one, what I have is, it says there are 3 times as many little hoop earrings. So the little hoop earrings, there's 3 times as many. So if I take the big hoop earrings and times it by 3, that tells me how many little hoop earrings I have. It tells me also that there's a total of 16. So little hoop plus big hoop is equal to 16. Once again, I'm going to substitute. 3b is equal to L, so I replace the 3b, and 3b and b gives me 4b, so 4b equals 16. If I divide it by 4, I get b equals 4. So that means there are 4 pairs of big hoop earrings. Now, if I take the 4 and I plug it into the B, 3 times 4 gives me 12. So there are 12 little hoop earrings. Now our last one. Evan finds a jar of nickels and dimes. He counts 8 more dimes than nickels. There's a total of $2.30. How much of each coin is in the jar? So for the first one, what I'm going to do is define the variables. So I'm going to have n, and that's going to equal number of nickels. And then I'm going to have d, which is number of dimes. So when I'm writing my equation, for the first one, it says 8 more dimes than nickels. So if I have the dimes, and if there's 8 more, then I take the nickels and I add 8. It tells me there's a total of $2.30. A dime is worth 10 cents, and a nickel is worth 5 cents. And that gives me a total of 2.30. Now, I'm going to times everything by 100, and that basically drops the decimals. That makes it a little bit easier for me since I don't want to work with the decimals. And then what I do is I take the n plus 8, and I replace that with the d. So I have 10, and instead of a d, I have an n plus 8. And then I have a 5n is equal to 230. So that would be 10n plus 80 plus 5n equals 230. So when I look at this, what I'm going to do is I'm going to combine the like terms, and that gives me 15n is equal to, and if I subtract the 80, that right there gives me 250. Then what I'm going to do is I'm going to divide it by 15. Oh, gosh, sorry about that. That would be not 250, it would be 150. And so then I divide the 150 by 15, and that gives me n equals 10. So there are 10 nickels. Now I have to figure out the number of dimes. So what I do is I take the 10 in for the n, and 10 plus 8 gives me 18. So there are 18 dimes.